Namaskar dosto, my name is Kalpajwal. You're watching Exercise Explained. So today we will be doing CBSE 10 Standards first chapter of the NCERT textbook, that is real numbers. So I would be solving the exercise 1.1 in this video. So all the questions will be completely solved. So without any further delay, let's make your questions simple. Use Euclid's division algorithm to find the HCF of 135 and 225. So Euclid's division algorithm basically tells A is equal to BQ plus R, where A is dividend, B is divisor, Q is quotient, and R is remainder. So here what we will do is we will basically take dividend as 225, divisor as 135. So 225 is equal to 135 into 1. See, 135 into 2 is going to give us 270. So 270 is definitely much more than 225. So what we will do is it will be 1 times plus we will subtract this, that is 225 minus 135, so that gives us 90. So 90 is going to come as remainder. Now what we will do is the divisor becomes the dividend, that is 135 comes here, and the remainder becomes the divisor. So we get 135 is equal to 90 into 1. See, 90 into 2 is going to give us 180, which is greater than 135. So it's going to be 90 into 1. So 90 into 1 plus 45. So now this becomes dividend and this becomes divisor. So 90 is equal to now 45 into 2 plus 0. So we can tell that HCF of 225 comma 135 is equal to HCF of 135 comma 90 is equal to HCF of 90 comma 45, that is equal to 45. Coming to the next one, that is 196 and 38220. So in this 38220 is clearly divisible by 196. So if we divide 38220 divided by 196, we get it as 195. So we can write it as, uh, 38220 is equal to, that is dividend is equal to divisor, that is 196, into quotient. So quotient is 195. Now since it is perfectly divisible, so remainder comes as 0. So we can directly tell that the divisor is the HCF. So that is what is the HCF. 196 is the HCF. Now coming to the next one, that is 867 and 255. Now 867 is equal to 255 into 3 plus 102. Now 255 into 3 gives us 765. So if we subtract 867, if we subtract 765 from 867, we get it as 102. So we write it as 867 is equal to 255 into 3 plus 102. Now what happens is this divisor becomes the dividend and this remainder becomes the divisor. So 255 is equal to 102 into 2 plus 51 comes as 102 into 2 gives us 204. So if we subtract 204 from 255, we get it as 51. Coming to the next thing, that is 102, that is this becomes the dividend, 51 becomes the divisor into 2 plus 0. So we can just write HCF of 867 comma 255 is nothing but 51. That is the last divisor which we have got. That's going to be the answer. Now the second question is pretty important and gets repeated. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. So in this what we will do is we'll take some x to be a positive odd integer. Now x can be written as 6 into q plus r. This is by Euclid's division algorithm, that is dividend is equal to divisor into quotient plus remainder. Now the remainder will always be less than 6. The remainder will always be less than 6. So here what we have written is 0 less than equal to r less than 6. So now what we would do is the the possible integers will be x is equal to 6 into q plus 1. I have taken it as q since that question wanted q. So 6q plus 0, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4, 6q plus 5. Remember 6q plus 6 will not be included because remainder has to be less than 6. So less than 6 means it will be 5. So this is going to be the last thing here. So now you can see here 6q plus 0, 6q plus 2 and 6q plus 4 will be rejected because these three will be even numbers and the question asked us odd integers. So here what will happen is we will reject these three and therefore the possible forms are 6q plus 1, 6q plus 3 and 6q plus 5. Getting into the next question, an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of column in which they can march? So column is something which goes up to down and row is something which goes from left to right. Please make it clear. I have seen many students having this confusion. So coming to the next thing, what we basically have to do is we just need to find the HCF of 616 and 32 here. So once we find the HCF of 616 and 32 by Euclid's division lemma, what we get is 616 is equal to 32 into 19 plus 8. So 32 into 19 gives us 608. So if we subtract 608 from 616, we get it as 8. So that is how this remainder comes here. Now after this what happens is the 32 becomes the dividend, 8 becomes the divisor. So 8 clearly divides 32. So 8 into 4 is 32. So 4 becomes the quotient and 0 becomes the remainder. So we can say 8 is the HCF. So maximum number of columns is going to be 8. Let's get into the next question, that is using EDL. Show that square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Now remember we need to find the square of any integer. Now what we would do is let x be a positive integer. So x will be equal to 3q plus r. This is by EDL, that is dividend is equal to divisor into quotient plus remainder, where remainder has a maximum limit of 3. You can see here. So the possible things, that is the possible outcomes here are going to be 3q, 3q plus 1, 3q plus 2. Now what we would do is, since the question had asked us square, we will be squaring each of them. So if we square x is equal to 3q, we get x square is equal to 3q the whole square. So that is nothing but 3 into 3q the whole square. So that is what happens is 3 into 3 is 9. So we get it as 9q square. So here what we get is 3 into m. We consider this 3q square as m. Now coming to the next thing, what we do is x is equal to 3q plus 1. We just square it off both sides. So we get x square is equal to 3q plus 1 the whole square. Now 3q plus 1, when we square it, it is of the form a plus b the whole square, which is nothing but a square plus 2ab plus b square. So that is what we have done. 9q square plus 2 into a into b is 2 into 3 into 1. So that is 6q plus 1 square is 1. Now what we would do is we would basically take out 3 common from these two terms. That is the first two terms, we would take out 3 common. And as we take out 3 common from the first two terms, we get 3 into 3q square plus 2q plus 1. Now 3q square plus 2q, we'll consider it as m and we can write it as 3m plus 1, where m is 3q square plus 2q. Now the third thing, we need to find the square of 3q plus 2. So 3q plus 2 the whole square, we will do x square is equal to 3q plus 2 the whole square. So that gives us, this is again of the form a plus b the whole square. So that gives us 9q square plus 2 into 3 into 2. So that gives us 12q plus 4. So what we get is, we write this 4 as 3 plus 1. So I've written it as 9q square plus 12q plus 3 plus 1. What happens over here is 3 into bracket of, we take common 3 from these three terms here where you can see my mouse. So what we see is 3q square plus 4q plus 1. The bracket closes plus 1. This one remains there. Now we consider this entire polynomial as m, and we can write it as 3m plus 1, where m is equal to 3q square plus 4q plus 1. So we can say that x square can either be of the form 3m or 3m plus 1. Getting into the next question, use Euclid's division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. So what we do is, we will take x to be a positive integer. Now x can be written as 3q plus r. So in this, what we would do is, r, the maximum limit is 3. So simple, like the previous question what we did, the first thing we would be cubing this. So 3q the whole cube will do. So x cube is going to be 9q cube, because it is x is 3q. So x cube is going to be 9q cube. So coming to the next thing here, so q cube is considered as m. So m is equal to q cube. Coming to the next one, that is x is equal to 3q plus 1. So we cube it off. Now this is of the form a plus b the whole cube, which is nothing but a cube plus 3a square b plus 3ab square plus b cube. So a cube becomes 3q the whole cube. So that is nothing but 27q cube plus 3 into 3q the whole square, that is 3a square, into b is nothing but 1, plus 3ab square is nothing but 3 into 3q into 1 square plus 1. So we get it as 27q cube plus 27q square plus 9q plus 1. So we take 9 common from these three terms here. So what we get is 9 into 3q the whole cube, 3q cube plus 3q square plus q plus 1. Now this entire thing is taken as m. So we get it as 9m plus 1. Now just like the previous question, we will again be doing x is equal to 3q plus 2. So here what we do is 3q plus 2 the whole cube. So that gives us 27q cube plus 3 into 3q square into 2 plus 3 into 3q into 2 square plus 2 cube. This is again of the form a cube plus 3a square b plus 3ab square plus b cube. So that is nothing but 27q cube plus 54q square plus 36q plus 8. So out of the first three terms we take 9 common, and what we get is 9 into 3q cube plus 6q square plus 4q plus 8. Now this entire thing is m, so 9m plus 8, where m is 3q cube plus 9q square plus 4q. I hope you guys like the video. Do share it with your friends and consider subscribing to the channel. Dhanyavad.